In this video we're going to be talking about the CSSA 2010 Extension 2 Question 4D. In this question we've so far established the result, the products, the sums, which you didn't have to memorize but you had to just find out from this question through compound angle formula. Now using this formula they're more interested in the volume as described below. It says the region R describes the area bounded by the graphs y equals to minus 4x and y equals to sine x on 2 in the interval from 0 to pi as shown below in this shaded area. A solid is formed with base R as in base of this region, and cross sections are equilateral triangles perpendicular to the x-axis. Now the 3D is not demonstrated too well in the diagram, you get the idea. Now they want you to calculate the volume of the solid formed. Notice how the first thing I did was I labelled the coordinates of the 2 points that is of most interest to you. Secondly, I have drawn the cross-section of the volume we're trying to find, and the cross-section is an equilateral triangle. Now the easiest way to find the area of an equilateral triangle, if all you know is one of the sides, is through the sine formula, half b squared sine 60, giving you root 3 on 4 b squared. Now from the diagram, you'll notice, if you have a look at the diagram, the length of the base is y2 minus y1. That's how long the base is. And according to the formula, the equations of these graphs, you can find the distance by doing y2 minus y1. So that's what we've done here. Now, because we're interested in the actual b squared, because that's what the area of a cross-section is, we must square the whole thing, giving us sine squared, 2 sine cos, cos squared. And of course, we have to set out our working out using the delta v squared, delta v equals to root 3 on 4b squared delta x, followed by how you would actually write out all of this. Now, unfortunately, this we know is easy to integrate. It takes a little bit of effort, but it's not hard. This is not hard to integrate, but this part is difficult because this is not the double angle formula for sine, because the angles are different. This is where we must go back up here to the result we showed earlier and ask ourselves, how can we apply this to get us to write this in a different way? So clearly what will actually happen is that A, in this case, will be the x, and B is the x on 2. So substituting all of that in, we can figure out this part in the pink brackets, and after that we work out the volume, remembering to write the volume as the limit of the sum and adding them all up. You should end up getting root 3 outside of 3 pi minus 4 all over 12.